The second test we're going to focus on today is called the P-series test. We talk about P-series and harmonic series together a lot. A harmonic series is just a very specific type of P-series. So a P-series just has this kind of a form. We are talking about a series where the denominator is n to some power. So you can see as we increment our n, we get 1 over 1 to the p, and 1 over 2 to the p, 1 over 3 to the p. A harmonic series is just a p-series. You can see where p equals 1. So each of these denominators is 1 to the first power, 2 to the first power, 3 to the first power. All right, so a harmonic series is a kind of p-series. So we can perform an integral test. We can use the integral test on any kind of p-series, right? And if you do that, if you take a few minutes to do an improper integral on 1 over n to the 1/2, 1 over n, and 1 over n squared, you'll notice that this improper integral diverges, this improper integral diverges, this improper integral converges. All right, and what that kind of points out to us is this general trend. When we have p-series, we don't have to do the integral test on it. We can, and it works, but because it's such a simple pattern, when we talk about p-series, we just have a very simple rule where if it's a p-series, that series will converge if p is greater than 1, and it will diverge if p is between 0 and 1. All right, or equal to 1. So if 0 is less than p is less than or equal to 1. So in order to get convergence of a p-series, we need p to be greater than 1. So these, once we know the p-series, these are pretty easy ones. Here we have a nice p-series. It starts off as n times the square root of n, but of course that's just n times n to the 1/2, which gives us n to the 3/2. So we can see here our p-value is 3/2. So since p is greater than 1, series converges by the p-series test. Pretty simple, right? If we get p-series, those are always nice because once we get them into that form, then they turn out to be really, really simple problems. So, today we talked about the integral test, and there's certain conditions which that function has to meet. So we need to always make sure that we test for those functions, that function is positive, continuous, and decreasing over the interval that we're concerned with. And then we talked about here the p-series and harmonic series. The p-series test being we're looking at that exponent in the denominator, and we want to make sure that it's greater than 1 to ensure convergence.